Hi, I'm Lars. Welcome back to the shop. This video is going to talk about how to increase your productivity, or just going to talk about productivity using your Onefinity. There's a couple different things if you're trying to increase productivity. One is using a jig, and that's the very first thing I'm going to go over, is just using a jig so that you can put a part in, take the part out, put the part in, take the part out, and just keep on going down that pattern. The second thing we're going to talk about is multiple offsets. And there's two ways to go about doing these. You can set a whole bunch of stuff up on your spoil board within a bunch of little jigs, which we'll talk about that in a minute. And you can just keep running this thing and then switching your work offsets every time you go through. Now, that's okay if you're doing, maybe 20 different items or whatever. But then there's the more advanced version of this. If you're ripping out like 100 items and you want to put 6 things on your spoil board to just get cut, you can combine, you can do some editing in your code, the G code, and make this more fluid. And then you would, should never leave your machine. I'm just telling you that right now. But you wouldn't have to be doing a lot of manual intervention while it was going along. So if you're up for this and this is what you're looking for, let's get to it. Now, the first thing that we're going to talk about here is offsets, but I want to just make sure everybody understands about what this guy is, because this guy is going to play a huge role in what we're doing with offsets. And if you watch this little probe up here at the top, when I touch these together, they're going to turn green. That's one way to test your probe. If you go to setup 1, you're going to get this password. Down here at the bottom, you just press that enter key, because they don't set a password, but they're still asking you for it. You can drag this down to probe, and if you touch these two together here, you'll see it'll turn to high. Okay, so the probe turns green, this probe down here turns high. Alright, so now we got that out of the way. Something, if you have a spindle, I'm going to scoot this to the side, and you take this magnet and you stick it to that bolt, or any bolt, any piece of metal, and just leave it there. You'll just be able to use this anywhere you want. If you can see this, and I touch this to the collet, you'll see that probe still works. Alright? I learned this from Bill Tracy from Terrapin Creations. I'll put his link below. He's got a lot of really cool stuff out there doing PVC. The first thing we're going to talk about is just putting a jig on your table. And how do you go about doing that? And a lot of that has to do with this thing called probing. Right. The table has a jig on it. It's just a square jig. If you want more information about this, and why I did this, how I built it, and everything else, and what I use it for, I use it for 15-inch wood rounds, to put a wood round in there, so I don't have to find the center of the round or anything. It's already set, and I'm using this as my work origin instead of the center of the round. Go out, look at, I got a video out there about the wood jig for wood rounds. It gives you instructions on how to make it. Now, this is a little odd, because what you need is you're going to need something like a piece of MDF if you're going to be doing this with a piece of 3/4, because this little guy is too short to set in here to probe. So for those of you that are new to probing, or just new to the Onefinity in general, and you're just watching this video, I do have an entire video series on F1, and then I've got another video on F1, F3, 4, 5, and 6, and they explain all this very thoroughly. I'm going to just give a quick little overview of this, and we'll be back to this again in a minute when we get to the next step. So if you're new to probing, you need to get to jog and probing, and then hit the little probing button. Now, this is a probing screen. It's broken up into 2 sections. The top section here is for determining if you're probing inside or outside. It's got your probing diameter, which is, my bit is a 1/8, so I got 0.125. Your feed rate, I really wouldn't make this any more than a 10, because if something goes wrong and you crash down doing a Z, you're going to destroy your bit and you're going to destroy your probe. Your X offset on here for the block, if you hold the mill where it's standing up, you turn this over, it's the measurement from this side right here, till it hits the inside of that. So you're going to need to get a set of calipers if you do not have them. The Y offset is the top to here, and the Z offset's the thickness of it. All right, very simple. Once you get these in, hit Save Settings. Now, you're gonna say, well, mine's already been set up by the manufacturer. Yeah, they did, but guess what? They didn't use this probe. They didn't use this probing block. So your probing block is brand new. It's probably not the same. It could have been over polished, could have been anything, and these numbers could be off. So do yourself a big favor and get a set of calipers and get this thing measured. Now, you need to hit Save Settings, and I cannot emphasize that enough. I've seen people put these measurements in and then hit probe and it takes off, and the settings have not been saved. My opinion, the screen, if any of these were changed, Save Settings should have lit up. What we're doing today, right now, is we need to get this block sitting in here like this. It's not going to be like the normal setup out here, because we need to find the inside corner of this. And yes, the reason this circle's here, if you do not know, is because when a bit comes in to a corner, it leaves a little bit of a curve. I don't care how small that bit is, there's going to be a curve. And if you put something in here as a nice square corner, it will sit and rock like this on it. And we want ours to be nice and tight. In order for us to do that proper measurement, we need to hit inside outside. Now you notice this warning, please save settings before probing. And that's great, but we need to know, we need to change these settings. So again, this is your probing block. If you turn this over, the X offset now for the inside will be the width of this. The Y offset will be the width of this, and your Z offset will be the same. So do yourself a favor and write this information down. I know a lot of people are going to say, I don't want to mess up my new table. Well, guess what? It's a lot easier to find something on your table than it is to go and look it up in a book or find that piece of paper that you put it on. So I'm going to put these numbers in here. So that's my X, this is my Y, and the Z is always going to be the same. And then I'm going to hit Save Settings. When I hit Save Settings, you'll see this change. So when you switch the inside outside, you need to hit Save Settings, because otherwise the computer, the software in here, does not know that you're doing an inside. This is now setting like this, same block, but now you're going to measure this corner here. You want it to come and hit here, whichever way it goes first. I don't know if it's here first or here first. So you're going to hit this bottom corner. So now I'm going to set this up over here. I'm going to put my block in there, and I'm going to run my little X, my little spindle over, and then I'm going to start dropping this out. I'm going to get close to it, but I'm not going to run this completely down. And I'm going to switch to step mode. I'm going to put this at 0.01, and then I'm just going to keep bringing down my Z until I'm below this line right here. Okay? And that's all I care to be, is I just want to be below that. Right now I am really close to the bottom of this. Now I can move my Y down a little bit and put that back on continuous. And now I'm going to press this inside corner. And it'll move back and it will do the X. Now if you do not have, and I could also do the Z here too, just hit the center of the block and it will pick up the Z. Then I want to get this out of here, because a lot of people would leave us here, move it on the X and snip their tip of their bit. Now you may be wondering, how would you do this if you had a deep well like a bowl? If you had a deep bowl, like a pocket bowl or something like that, some pocket to do this in, I've actually done this by measuring the thickness of this with the and putting the Z value in for my X and Y, and then I've stood this on the side like this, like laid it against it where it was setting in the bowl. Like if this was the side, I've set it like that and run into it. That works well. But you got to realize these Massos are not made for just wood, and the predominant people who use the Massos are using them on metal CNC machines, metal lathes and stuff like that. So this would all be metal. So from this here, if I had 3 pieces of stock sitting out, okay, say these were just 3 blank pieces of stock, I could take them, move this out of the way, drop them in, or leave this in place since I've got my Z, drop them in, you know, secure them down, cut it, take this out, put this in, cut it, take this in, cut this out, and cut it. Now, it would not matter how big that piece of stock was. You could have 5 different, completely different size pieces of stock. As long as you had a straight corner, straight edge on it, like this corner was a 90-degree corner, so this edge was straight and that edge was straight, you would be 100% fine. And if you're not doing a lot of parts or pieces, this is the approach that I would take. Hands down, this would be the easiest setup to do. It only took us like 5 or 10 minutes to get this set up. Alright, let's move on to the second one. Alright, for the next part of this, we're going to go to F4, Tools and Offsets, and I'm going to talk about these offsets here. You only have 6 of them, so you could use G54, 55, 56, 57, 58, and 59. Right now, if you look at the top, if you can see this up here, it says work offset is G54. So that is my work offset. You have to be very careful about using these offsets and thinking that your software in here, whatever you do here, is going to change the offset, because you could change these in code, and I will show you that a little bit later. But jogging and probing, if you go back to probing and I hit G55, notice my work offset's G55. If I hit G56, it goes to 56, 57, 58, 59. So depending on where I'm sitting, this will get changed. If you're going to do a setup where you're just putting out 3 different offsets, make sure you write on them G54, 55, and 56, so you know which ones they are. You could lay them out on your board where you go G54, 55, 56, 57, 58, 59. And that would work too if you can keep them clear in your head. But I don't advise saying G54, 55, 56, 57, 58, 59, because you're going to forget where they're at unless you mark them. Now I've got just 3 pieces of wood here because I'm just going to simulate what I'm going to show what happens when you start using multiple offsets. But if you were doing this on, say, 36 pieces or, you know, 360 pieces, you're going to want to build some sort of a jig. You can do it very easily by just putting down a piece of wood, grabbing a speed square, make sure it's straight with your spoil board, and set down a piece of wood like that, make sure everything's straight, and screw it down. And then taking your speed square, once you get that one in, bring it on the side, and putting a piece on the bottom here like this. I've got things running in my way, like this, and put another piece in this way. And build a frame, like a window frame if you will, someplace that you can set stuff in. The second way you can do that is you can take and build some sort of an L system like this, for smaller ones, and you could set them in place, and then you could put a part in. This way you could take and you could put a part there, pick that up, you could put another part in, pick that up, put another part in, and as long as you're using that G54, because this one is G54, it would work just fine, and you could rapidly get through your product. Instead of having to go in and set XYZ, 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 you would have to just go in and put Z. Now if all of your wood is the same thickness, you wouldn't even have to go in and hit Z. Okay, you can just put a part in and run it. So that's up to you, whichever way you want to go about. If you did do the window frame and or an L, you know, put a square in its place, you'd have to use the same probing technique that we just went over in part 1. Now I'm not doing that. I'm just laying out my wood with the idea that this is just going to be clamped down as it is. These are squared to the front of the table, and I'm going to pick up that work origin. And this is how we do that. The first thing that I need to do is I need to set this back to outside. So I'm going to come in here and change these back out to what they were. I'm going to hit save settings, and that's going to save this information to the firmware, and then I get my output, my outbound again. So I need to pick these up. So I'm going to pick up the first one's G54. I'm going to make sure I have this hit. I'm going to make sure my work offset up here at the top here is set to G54. So G54, work offset G54. Now I can touch that button when I put the probe on. So now I can take the probe, set it on this corner piece. I can bring my board back. I can bring my spindle back, drop it down, about like that. And I'm going to put my hand on it. I'm going to hit that top right corner on the box on the screen. I'm going to touch off. And we're going to go the other direction because we're doing outside. There. So that's set to G54. Now we're going to move over to G55. So I'm going to hit exit probing right now. I'm going to go to tools and offset, and you're going to see that G54 says 131177 -348 because we're coming down. Remember, Z always comes down. Going to go back to jogging and probing. Going to hit probe. Going to hit G55. You're going to see the work offset here at the top. It's changed to G55. And then we're going to hit that button right there once I get the spindle moved over. And then this will be G56. And as you can see, if we hit exit probing, we go to tools offsets. Now this is 2238 -354. There could be some fluctuation between the piece of stock that I'm using. G56 right now is set to 29.3. We're going to go back to jog and probing. We're going to hit G56, and then we're going to hit that button. And again, we're going to hit exit probing, F4, and now you're going to see we're at 32 instead of 29. These are 3 individual work origins. What can you do with these work origins? Well, if we go back to programming in MDI, we don't have a program loaded, so let me get a program loaded up here. Go to load file, and I'm going to go down to tests. Okay, I think everybody should have some sort of a test program. I have a square that I do tests out, especially if I update my software. I want to make sure that I'm getting the exact same data back. We're going to go to MDI. We're on G56 right now, so if I was to hit work origin, that's now lined up with this corner. That's where we said the probe would be. That's where the corner would be. It'd be no different if we would have set up the inside of this inside of a jig. Okay? Be in the same spot. Now let's go back to probing. Probe and hit this to G54. Okay, so up the top here, this changed to work offset G54. We're going to go back to programming in MDI, exit out of probing, or we could just leave probing up, doesn't really matter. Now when I hit work origin, it's going to go over to that offset. And if I hit G55 and I say go to work origin, it's going to go to that offset. And I could run this program every time I say go to G54, 55, 56. If I hit run program, it's going to run that exact program, and all of the coordinates that are in the program are going to be based off of that work origin. This is the version A of the second way to do this. So let me continue down this path here. Now something I'm going to show you over here in the code, we're going to go back to load file, we're going to hit edit. And I know not a lot of people get into coding, but this is what I do for a living. I'm actually a C# architect and developer, and I've been one for 48 years. This is no different. This is just G code. This is generated code that somebody created using a language like C# or Java or something like that. I would never use Java, but that's okay. If you go down through here and you see your ends, You see G90, G94, G17, G80, G20, G55. These all do things, all right? The ends don't really matter. The line number, that's just there because we're humans and we need to say, hey, you're on line N90. I can't remember what all these exactly do, but like G94 I think tells you you're going to be in inches instead of metric. If it's G93 or 5, it goes to metric. That's all these things do. Now, as you can see in this application, this is all it is really just drawing a square. I don't have anything in here that says G55, G54, or anything like that. All right, it's not here. And the reason is this way I could use a different offset if I wanted to, just for the test. Now, if I go up to something else, so if you look at the editor and the bells here, this is something that came in from Fusion 360. If somebody's out there and they need this file, just contact me. I've got it up on a OneDrive and you guys can have it. I've put it out, I've posted it many times in Onefinity, but someone keeps taking it down. But if you go down through here, you'll see there's at N220, there's a G54. This is telling the machine, go use offset G54. So if you set all this stuff up and this work offset up here says G55 at the top, okay? Let me step down through this. I'm going to exit out of here and I'm going to go back to programming and I'm going to hit single block. And we're just going to hit Control Start and we're just going to go down. Now this is going to tell me change my tool because the last one I ran had a tool for 1/4 inch. I've got a 1/8 inch in there now, but just for samples. But this one here demands that I need that. So in order, my spindle just moved forward to where I do my manual tool replacements. So I just need to hit cycle start and then it will move back to the work origin. Then we do a G17, a G90, a G94, and if you keep an eye up here at the top where it says G54, a G55, right there, when we land on this, because when you land on them is when they execute, we just switch that to offset G54. So even though my machine is sitting over here at G55, it's going to actually take the process for G54. So I'm going to keep on stepping down. I'm going to show you this because nothing's going to happen because I don't turn my spindle on until the last second. So here's my code to avoid all my clamps. We brought it down. Now we're going to go to G000. Now that would be really bad if you had your spindle running and you were down right on your board. You would have snapped that bit lickety split across your jigs. That's why I do not turn mine on. The reason I'm showing this is because all of the code after G54 got put in there is based off of that offset of G54. So that work origin where it's sitting is where it's at, okay? We thought it was going to be over here at G55. It's actually back here. Now if I was to keep on stepping down through this, see, it's going to start carving my bells up there. Well, I might not have any wood up there, right? My wood's sitting over here on G55, right here. So that's why you have to watch out for those G54s, G55s being in your code. Now let's go back into my office and I will explain this a little more in a better environment. Now that we're back in the office, I can go over a little more detail about what's going on in the G code. The first few columns here, the first up to the first space, is your line number. This is normally here just for human beings, but we still take the practice of going 10, 20, 30, 40. We don't do 01, 02, 03, and we don't do 10, 11, 12, because you might have to slide something in between these two numbers. And if you're trying to debug code when you're down here into the 18,000s, you end up trying to figure out where you're at. Now this number here will probably repeat a bunch of different times, okay? Sometimes it could, so you just can't count on that. So the line numbers are very important. In today's coding, we even still use line numbers in C#. If you're looking for, things, you can read code a little easier, but you can still find it.
when we were out in the shop, I couldn't remember what the functions were for G90, 94, 17, 18, and 20. So I looked them up and I put a comment in here so you guys can see them. If anybody needs this for Fusion 360, the post processor, just drop me a note, let me know, and I will get it to you. I have it up on OneDrive. I can send you a link. The reason I name my files like this is step one, because there might be 2, 3, 4, 5 different steps for something. It also tells me what bit I need to use, so I don't have to come in here and find tool number 3 and figure out what it is. It just tells me it is a 1/8. All my tool numbers are set up the same. And then it gives me a description from Fusion 360's point of view of that this is a 2D adaptive, or it's a clearing, something that will clear out an area of your stock. There's also some other information here. These are all just about the machine. So G90 tells the machine I'm doing absolute positioning. There's two different types of positioning. There's incremental and there's absolute. Absolute means you're going to take the work origin as 0, 0, and every point that you're referencing, any measurement you're doing, is always going to be referenced back to 0, 0. Incremental is you're going to measure off the last position you were at. G94 is a per minute feed. The G17 says select the XY plane. You could also have selected the ZX or the ZY plane. Not for your Onefinity, you can't, but if you had a 5-axis, you could. G80 cancels all your cycles. G20 gives you the imperial units. G21 would give you your metric unit. So if you're using metric, this would be a 21. There's just some more content comments here, and then there's my own code that I add to avoid clamps. And I don't turn my machine on to the very end, so I added more code down here. For Carveco and Fusion 360, they tend to do your tool change. They reset all your XY plane, absolute positioning, and everything. I have my Fusion 360 set up to choose my work origin. I could take this out. It doesn't really matter. But normally what would happen is this S16000 MO3 would be sitting up here someplace. And then it would move to here, move to here. I don't like having a spinning bit outside of my work area. With all that set out there, the G54 is from this point forward, once the work origin is set, every direction, every G code given to the machine after that is based on this work origin, based on the absolute positioning. Okay, so it's based on this work origin. So when we say we want to go to 2 inches, we're going to move 2 inches. We go to X0, Y0. Well, that is the work origin. And then we're going to say go to 4.5 and 8.6. That's going to move off based on where that work origin is. And so is all the rest of these. This is part B of the version 2 of how to, set up this system with Jigs. You could take this and you could copy it all the way down to the bottom. Now notice there's 992,990 line numbers just for that code, because these are the bells. Remember, there's a lot of intricate things that are going on. What I would do is I would take this all the way down to, we got to the 0.6. So we're going to raise the drill bit up, or the mill up. The mill's going to come up. You're going to stop your spindle. Your coolant's going to get turned off. We don't use coolant. It's just good practice. Then we're going to raise it up to 2 inches. And then we're going to bring it back to the origin. I would take from G54 all the way down to this point here. This is also my code. Once my bells are done, I raise it up to 0.6. I stop the spindle. Good habit just to turn off the coolant. Then I take it up to 2 inches, and then I go back to the work origin. So if you were to copy that code, hit enter a couple times, and then paste it, you'd have to go back to the beginning and do a search for G54, and then search again, and that would put you to the top of this. Then you'd have to put a 55 in. And it would now set the work origin to 55, and your code would start executing based on that 55 work origin. And you would do this again to 56. Now the issue that you have is that these numbers should still be incrementing. But that's not absolutely necessary to run your G code. As long as you don't have a line spacing here, none of these spaces matter. All this code used to run just smashed up against each other like this. All right, so all this code here would run. There was a while ago when code used to run on a paper tape. There were no line numbers. You didn't have any spacing in between. It just runs. So what happens when this code gets read in by your application is it's looking for G55. Okay, it's looking for a G and it's going to go G55. Then it will look for the next G or M. That's all this does. Depending on what the G code is, like G00 or G0, you don't even need a 00. It will look for the X to Y, and it will look for a Z if it's there. If there is no Z there, it just keeps on looking for the next G, okay, or M or S or whatever. So all these comments are in here. They're just for humans, and so are the numbers. Now, if you do want to do something with this, just because it's irritating you or something, there is a way to do that. If you are a developer and you know any language that can read a file, you can go in and you can renumber this, and just renumber all the lines all the way down. So if you started out with N10, N and then like a count of 10, and then just added 10 to it, you'd have 20, add 10 to it, just on and on and on for every single line in the file.
I really hope you enjoyed the video. Please like and subscribe to the channel. It really helps us out with the YouTube algorithms that are out there. If there are other videos that you guys need, that you are interested in or trying to figure something out, drop them in the comments. Send me an email. If I got the time, I'll put a video together. I don't have any problem with that, as long as I know what I'm doing, right? I hope you guys really enjoyed watching the channel. I hope you guys get a lot out of this. You're always welcome back here in the shop. And as always, have a nice day.